Hello, I'm Sergio and we're about to showcase one of my portfolio pieces. It's called Star Notary and it's an NFT marketplace for registering and trading stars. We're going to use 4 terminals for this. One for the database, 2 for the backend services, and 1 for the front-end server. I'm going to go ahead and make them big. But first, we gotta check the unit tests, of course. So we're going to start with the Solidity NFT smart contract. Good. And now the front-end tests. Yep. And finally the back-end tests. Awesome. All tests are passing. We feel good. Let's move on. And now to run the application, first the database, then the backend API, then the contract listener, then the front-end server. Okay, that's it. This is the app. Now this is just an info prompt saying that you need a MetaMask wallet, some fake internet money for gas, and that the contract uses the Equatorial Coordinate System, or RADEC, in the J2000 epoch for registering stars. This was a chosen standard because it's pretty stable, is the most widely used, and it's reasonably interchangeable with the extragalactic pulsar-based coordinate system, the ICRS, which is the most stable. But anyway, we can close this. This won't show up again. If you want a more detailed explanation on the coordinate system or on blockchain, I'll leave a video in the description down below. But this is not a video on astronomy or blockchain. This is a showcase, so moving on. As you can see, this page shows us all of the stars that are registered in the NFT contract. But at the moment, there's nothing we can do with them. That is because we failed to click the giant button in the top right telling us to connect our wallet. So let's connect MetaMask, and there we go. Now we are connected and you can see a lot more information and buttons. That is because this wallet owns all of these NFTs. I created all of them using it. So we can take actions such as putting them for sale, changing their name, or in case they were already for sale, changing their price or removing them from sale. But it also tells us we are connected to the wrong chain, and indeed we are. So I'm going to click this button, and I'm going to click this to switch chains, and I'm going to confirm in MetaMask, and there we go. Now we are connected to the right chain. If we had tried to take any of these actions while connected to the wrong chain, we would have gone through the same workflow. It would have shown the same modal. But instead of taking any of these actions, I'm going to show you how to register a new star. Okay, this is the Create Star view, and I've reloaded the page just so the wallet disconnects so I can show you what happens if I try to create a star without having a wallet connected. And I'll just input some values that I know to be unique. You might have noticed that all star names and coordinates are placeholder for the purposes of this showcase. So let me just put this in. And you can see I'm navigating using the keyboard. This entire web app has keyboard navigation with field highlighting and auto scroll for maximum ease of use. And this was implemented from scratch using JavaScript. Before we do this, I'll just prove to you that this star NFT does not exist yet by querying the contract directly on Etherscan. Now, all star NFTs are created with incrementing IDs. And I know that the latest ID is 66, so this next one will be 67. So all we have to do is go to the contract page on Etherscan, click Contract, click Read Contract, then scroll down to this function, Owner Of, and we're going to query the token ID 67. And there we go, we have an error. Owner query for non-existent token. This token, this NFT of ID 67 does not exist. Good. Now we go back, and of course it won't let us because we weren't connected, so we just press enter and it drives us straight to the connect button. Press enter again, now we are connected, and now we submit. Confirm on MetaMask. Now, those toasts are going to keep updating us on the transaction confirmation process. For Ethereum, we're supposed to use 12 blocks of confirmation, but I've decreased it to only 2 for the sake of brevity, and the system will not register any action without all the confirmations, so we just have to wait a bit. And patiently. Okay, there we go. Our NFT was minted and it was registered and added to the list. And you can see that it's owned, meaning that this connected wallet currently owns it. But now I'm going to prove it to you by querying the address again. Now we're going to query for 67 again. And there we go. We have this wallet, B9D, ends with 96B. And if I take a look at my wallet on MetaMask, there you go. I don't know if you can read it, but here it is. I'm going to copy it here. Starts with B9D, ends with 96B. Here. Now, before we actually make a trade and prove this as a marketplace, let's touch on some implementation details and features. This front-end client is a React SPA. As far as dependencies go, it uses TypeScript, React, React Router, Redux, some utilities like Axios and .env, as well as Web3 for communicating with Ethereum, and also Jest for testing. As you can see, it has sorting, pagination. You can also change the size of the page, bigger page, smaller page. I didn't really get around to filtering or searching yet. I might do this in the future. And for thoroughness, the backend services are basically Golang standard library with some dependencies related to Ethereum logging and environment variables, and the Solidity NFT smart contract inherits from OpenZeppelin's ERC 721 contract for its implementation. It's also important to note that all of these style and the animations in this web app are just vanilla CSS 3. There are no CSS frameworks or processors, and the CSS is quite organized using the BEM class naming pattern. This is Flexbox being put to work, and it's responsive. It works down to about 300 pixels of width by leveraging relative units and media queries, so it should be able to work on any mobile device. Now we'll finally trade a star. But first, we need to put a star for sale. So let's put for sale the star that we just created, star 67, for 0.1 Ether. And confirm. Okay. While we wait for the confirmations, let's understand a bit more about the setup. We have one wallet connected to the Chrome browser and another wallet connected to the Firefox browser. Let's give them names. I'll call them by the first 2 digits of their address, which is usually pretty unique. So the B9 wallet is the Chrome wallet, and the 8A wallet is the Firefox wallet. What's about to happen is the Chrome wallet, B9, just put star 67 up for sale, and the Firefox wallet, 8A, will purchase it. And we just saw it dynamically turn into for sale in the Firefox browser, even though we put it for sale in the Chrome browser, because on startup, the web client will connect to a WebSocket endpoint that is exposed by the backend API, and the backend API will then broadcast all actions that it confirms to all connected clients. So that's why this dynamically changes. Now we'll purchase it with the 8A wallet. And now let's quickly check how much money they have in Ether. 8A has 0.6 and oops, B9 has 0.2. Now, just for fun, Let's wait for the event of the star being purchased to come to the Chrome browser via WebSocket. And while we do that, we can also simulate some some mobile devices just for fun, so we can see. Oh wait, it already happened. Okay, so let's check how much money they have now. B9 wallet has 0.3 and 8A wallet has 0.5. And now if we come here to the contract directly using Etherscan and query again for which is the owner, which wallet owns token 67, before it was B9, I'm going to query that again, and now it is wallet 8A. Finally, let's discuss in a little bit more detail the architecture of this application so you can understand what's happening. Anytime a client takes an action in this application, it is publishing a transaction that will change the NFT smart contract's state in the Ethereum network. And it does this through an RPC provider. And the RPC provider is just a service that allows for a program running outside of the blockchain to more easily communicate with a blockchain node. This is useful because blockchain nodes are not always integration friendly. They have their own protocols for their own internal functioning. And the RPC provider not only exposes endpoints that facilitate information gathering in a way that wouldn't be possible communicating directly with a blockchain node, but they also expose these endpoints in different application layer protocols, such as HTTP or WebSocket. So the client takes an action, the action changes the state of the contract, and then there is this service, the listener service. The listener service is listening for changes in the state of the contract. This is possible because you can program your smart contract to emit events. So when the contract changes, the RPC provider communicates with the listener service. The listener service understands which action was taken, how the state changed, and then it awaits a certain number of confirmation blocks while querying the RPC provider to figure out if after all those blocks that transaction that changed the state is still valid. If it is still valid, it will consume the backend API that will not only register the confirmed change, the confirmed action in the database, but also broadcast this action to all connected clients through WebSocket. That's basically what's happening. Well, that's it for the showcase of this NFT marketplace I've built. I thank you very much for watching, and I'll catch you next time.